Hi, Year 9. We're going to go ahead and introduce ourselves to the trigonometric ratios. So we have a little flashback for us. I'm going to put a brain bubble over on the side. And we already know that Pythagoras' theorem is used to relate three sides of a right triangle. However, we have not mentioned anything about the interior of the right triangles. So if we are given a couple right triangles, let's first establish some common vocabulary, okay? So if I start to look at a triangle and note that there is a certain angle in the corner, so I'm going to be using this theta. This is a Greek symbol called theta, and that basically just means you're talking about the angle inside the triangle. So if I were this theta and I'm in the top corner, some vocabulary that I'm going to use is if I'm in this top corner, then this side would be opposite to me. This side would be adjacent to me, and this side would be my hypotenuse. Now, if theta moves around, let's say theta moves down to this corner, now suddenly we have a couple, we're using the same three words, but they might be in a different location. This theta now has this side opposite to it, and this side is adjacent. So start thinking what the word adjacent means. I like to think of it as next to, all right? And then I still have my hypotenuse in the same place. And last but not least, my last option would be the 90-degree angle, okay? Now, with 90-degree angles, we don't necessarily use the same vocabulary because the opposite side is the hypotenuse. And we just call the two sides that make that 90-degree angle your legs or your adjacent sides, okay? So our new scenario is really this one, when the angle's in the top corner, or this one, where the angle's in the bottom right corner. So what we can start doing is we can start saying that if I want to look at, if I have an angle in this first scenario, and I want to look at how to find that angle, we can use something called a trig ratio. And these are ratios that help us find the angles that are inside of a right triangle besides the 90-degree angle. So one of them is called sine, which is spelled S-I-N-E, and it's shortened down to S-I-N, and then we always put an angle in sine. So we talk about sine of the angle. And sine of an angle always refers to the opposite divided by the hypotenuse. So if I were this angle up here, I'd be looking at the opposite side divided by the hypotenuse. Okay? My second trig ratio, we said there were three of them, is spelled cosine, and it's shortened down to cos, C-O-S. And again, you always put an angle. You always talk about the cosine of an angle. And that is your adjacent side divided by your hypotenuse. So if I were standing in this corner, I would want to take my adjacent side and divide by my hypotenuse to look at the ratio to find my missing angle. And the last trig ratio is called your tangent, and that's shortened down to tan of an angle, theta. And your tangent is always your opposite. I'll shorten that to OPP, opposite, divided by your adjacent. All right, so if I had an angle that was in this corner, I would want to take the opposite value and divide it by my adjacent value. So depending on where your theta is, I'll have to look and see what the opposite and what the adjacent are in that scenario. So an easy way to remember your sine, cosine, and tangent is if we just simplify it down to the first letters. Okay? So my first letters, my sine is equal to my opposite over my hypotenuse. Cosine is equal to adjacent divided by hypotenuse. And tangent is equal to opposite divided by adjacent. If you're having trouble remembering the order that they go in, some students have just made a mnemonic device, and they've said, well, if sine is opposite over hypotenuse, let's call that so, and then C, your cosine is adjacent over hypotenuse, let's call that ca, and then your tangent is opposite divided by adjacent, let's call that toa. So if you're having trouble remembering the order, it's so, ca, toa. So if that helps you remember, use SOHCAHTOA to remember how to actually set up your trig ratios. So let's look and see what we'll be expected to do in class. Label each side as opposite, adjacent, or hypotenuse. So you'd have to be told that first of all, this is a right triangle, and secondly, you'd have to be told what corner your theta is sitting in. So let's say my theta is sitting in the top corner. Then according to that theta, this side would be opposite. This side would be adjacent because it's right next to it. And this side is always my hypotenuse if it is opposite the 90-degree angle. Something else I might be expected to do is to write a trig ratio for this triangle. So I could write sine of theta would be opposite, so my opposite side is the 12, divided by my hypotenuse, which is the 13. Or maybe I could write cosine of theta, which is adjacent, so 5, divided by my hypotenuse. So here's my adjacent side, divided by my hypotenuse, which is still 13. It has not changed. Or maybe you'll write your tangent. So tangent of theta would be opposite, which is 12, divided by adjacent, which is 5. Okay? So you would have three options if the directions just said to write a trig ratio. So I could have chosen any of those three to write. And last but not least, let's try to write a trig ratio for this diagram. So if you notice, my theta is in this bottom corner. So according to theta, I have a side that's opposite to it, and I have a side that is the hypotenuse. The side that I'm missing is the adjacent side, so I don't want to use anything that would have an A or an adjacent in it. So if I think back to my SOHCAHTOA, I add my equal signs in, I don't have the adjacent side, so I can't use cosine and I can't use tangent because they have the A for adjacent, so I can't use those. So I'm going to have to use sine of theta is opposite, so 4 divided by hypotenuse, which is 6. So right now we're just getting used to what the three trig ratios are and then how I can actually apply them to a diagram. Have a good night, guys. I'll see you next time.